as I was saying a minute ago before I get interrupted, what defines a solenoid is important. So it's more than just coils of wire. So I'm not going to give you a hard definition, but what distinguishes a solenoid from just a few loops of wire is the length of the solenoid is much greater than the radius. All right, so if this is the length and this is the radius, okay, you want it to be fairly long. If it's just a few coils of wire, then the assumption that the field inside is constant does not work. Okay, so again, I will show you the second-hand rule. I'll do an example in a second, but I'm going to guess that, you know, how I applied it is difficult without seeing it directly. Maybe not. The reason we want to create a solenoid besides a uniform field is we can create a much stronger magnet by concentrating those field lines. In other words, when I draw those field lines in here, okay, and even when they come out, they're fairly close together, especially at the poles. And so we get a strong one, and it's essentially a bar magnet. Whereas if I have just a straight wire with a magnetic field and the loops are going like this, there's no concentration of them. They're just spread out along the length. So there are three ways you can make a magnetic field stronger in a solenoid. I'll demonstrate this if I haven't done so already. The most obvious thing is to increase the current. Okay, the more current you have going through the wire, the more charges you have moving per unit time, the stronger it's going to be. But there's a limit to what you can do with that. The easiest thing you can do is to have more coils. And we're going to see coils of wire are the heart and soul of any device that uses electromagnetism, and there are tons of devices that use it. I'll talk more about those in class. So it's easy to wrap coils 500, 1,000, 10,000 times if you have thin enough gauge wire and you just make multiple layers. The last thing that's the least obvious is what you put in the middle of this. So the solenoid I showed here would be an air core solenoid. In other words, just assume to be air in the middle. But you can enhance the field by putting materials in there that become magnetized, if temporarily, when exposed to a magnetic field. And so a great material for this, iron. So if you put an iron core in there, you can get even a stronger field. And I'll show you a dramatic demonstration of that. So let's do one more example before we finish this. I have two electromagnets next to each other. I want to know, will these attract or repel, right? This is going to be a pole, this is going to be a pole. We want to determine essentially, are they going to be north, north, south, south, or north and south? And you can see that there is connected to a voltage source. So we can work this out, all right, before we apply the rule. So what we first want to establish is what is the direction of the current as it goes across the front of the face, as indicated by these wires. Once we have that, we know how to curl our fingers. So if we're following conventional current, out of this voltage source, here's the positive, it goes down and back and then comes up, and it's going up in front, down and back, up in front, etc. Okay, so that means I've got to curl my fingers in front of it. Maybe hold your pen, curl your fingers in front of it, and then wrap them behind it. If you do that with your right hand, you see your thumb points to the left, which means that the north pole of this electromagnet is on the left. So this is going to be a north, and that's going to be a south. Do the same thing with this magnet. So here is a current coming out like that. It's going up behind, down in front, down in front. So I want to hold my pencil such that my fingers curl up behind it and then down in front. And I see my right thumb is pointing to the right. So this is a north pole and this is a south. So they are going to repel. Okay. So if you got any questions, make sure you ask. We're not going to do an equation for the magnetic field strength of a solenoid. It is different than a wire, but it has some similarities to it, but it's not part of our curriculum.